All right, starting with section 4.2, what do you notice about this graph that I had you draw? What are some things that you notice about it? What do you mean they're kind of the same?
Well, I mean, one's a little bit bigger, but the arrows are kind of the same, just different sides.
Are you talking about the red lines?
Yeah.
Yep. So we're used to the equation f of x equals x. That's kind of our standard parent function. Okay. But this function that you see on this graph is 1 over x. It's a variation of 1 over x. Okay. That is the reciprocal function of our original function. Okay. Remember, reciprocal means you flip it upside down. Okay. So this is our reciprocal function. So it looks flipped. Here's my one side of the graph. Here's the other. They are inverses of each other. What else do you notice?
Like they're on the same line, the like dotted line.
What do you mean by that?
One side of it like lands on there. Yes.
Are you meaning where they're at in relation to these lines?
No, that's the
I like how you said they follow the line. Okay. Do you notice that these red lines, both of them, do not touch the blue or the green line? Okay, we all notice that. Okay. We are going to focus on those blue and green lines today. They are called asymptotes. Write that down. Asymptotes. Our blue and green line, those are called asymptotes. Okay, today we're going to be talking about vertical and horizontal asymptotes. Okay. The green one is your horizontal asymptote, and the blue one is your vertical asymptote. I want to focus on that green one real quick. What axis is it going through? What axis is the green line going through? It's going through the y-axis at what point? It's going through at y equals 4. So our horizontal asymptote is y equals 4. Okay. I know it might be a little different on your graph because yours is smaller, but looking up here, what axis does the blue line go through, our vertical asymptote? What axis does it go through?
threes.
Goes through the x-axis at x equals 3. Okay. So when we were talking about x-intercepts and y-intercepts and all of those, remember when we wrote our answers, we had to write it as x equals and y equals. Same thing with asymptotes. We have to be particular when we're labeling them. Okay, so we have asymptotes at y equals 4 and x equals 3. Those asymptotes serve as boundaries. Okay, what I mean by boundaries is that the graph will never touch those two lines. Okay, it will never go across. It will get very, very close, but it will never touch those lines. Okay, they kind of serve as walls or barriers. Okay, so we're going to be focusing on those asymptotes today. So we're going to talk about finding vertical and horizontal asymptotes. We're not going to spend time graphing these. Okay, we are going to spend more time on just finding the asymptotes. Okay, so I want to look at this example real quick. Not in your notes, but I want to look at this example before we do one in your notes. So we have this rational function. What do I mean by rational? The term ratio. Rational functions are functions that are in fraction form. Okay, so we have a numerator and we have a denominator. To find our vertical asymptotes, I want you to write this down. Vertical asymptotes. So to find our vertical asymptotes, we are going to set the denominator equal to 0. And then the next step is going to be factor and solve. I want you to understand with the vertical asymptotes, we're always going to write our answer as x equals whatever our asymptote is. Okay. So notice that finding your vertical asymptotes is the same as what we've been doing before. We're just applying it to a new concept. Okay. We have factored and solved before, yes? Okay, we've done that a lot. So, the new thing that we might not have talked about lately is denominator. What is a denominator? The bottom of what? It's the bottom of a fraction, right? So what is my denominator on my function up here? X squared plus 7x plus 12. What does it say to do to the denominator? Set it equal to 0. Okay, so now it's just a matter of factoring and solving. How do I factor that? What does it mean by factor? Yep, find the factors of 12. What are my factors of 12? 1 and 12, 2 and 6, and 3 and 4. Which one of those pairs will get us to 7? 3 and 4. So remember, when we find our factors, we can just rewrite x plus 3 and x plus 4, remembering that we still have it equal to 0. So now, how do I solve that? How do I find my particular x values? What do I do with both of them? I have x plus 3 equals 0 and x plus 4 equals 0. So we solve them separately like we have been. So how do I solve x plus 3? Subtract 3. So I have x equals negative 3. What about x plus 4? Subtract 4. X equals negative 4. So those two values right here, those are my vertical asymptotes. Depends.
How do you know?
Well, just like we did with before, whatever the degree is, that's how many solutions you're going to have for vertical asymptotes.
So when you put x equals blank, then it'd be x. Then you'll write that.
So on your example 2a, we are finding the vertical asymptotes. What do we do to find the vertical asymptotes? How do we get started?
Set it equal to 0. Denominator.
Yep, set the denominator, which is that bottom part of the fraction. So we have x squared minus x minus 6 equal to 0. What do we do after that? Factor and solve. Yep, what are factors of 6? 1 and 6. And 2 and 3. Which one is going to get us to negative 1? Yep, 3 turns negative. So we turn this into x plus 2 and x minus 3. Reminder, it's still set equal to 0. So how do I solve from here?
Just do the opposite.
Right, so we're going to set both of them equal to 0. So x plus 2 equals 0 and x minus 3 equals 0. So when you end up solving, you do end up getting the opposite. So x equals negative 2 and x equals 3. What are those again?
Vertical asymptotes.
Those are vertical asymptotes. Okay. Again, what are asymptotes on a graph? What do they do?
They're the green blue lines.
They're the boundaries, right? The graphs, do they cross them or touch them? No. Okay. Go ahead and flip your notes to example 2b. Similar idea. I want to find the vertical asymptotes, but what do you notice about this one? What do you notice about the denominator? What? Right. Is it already factored? It's already factored for you. So we can even skip that step 1 and we can go straight, we can skip the factored part. We know we still set the denominator equal to 0. So we have x minus 5 times x minus 1 times x plus 3 equal to 0. So how do I solve from here? What do I do with each one?
Set it equal to 0.
Set it equal to 0 separately. So I have x minus 5 equals 0, x plus 1 equals 0, x plus 3 equals 0. So I solve all of them separately. So I get x equals 5, x equals negative 1, and x equals negative 3. Again, those are our vertical asymptotes. So now we're going to talk about finding horizontal asymptotes. You're going to take a little bit of notes and I want you to take them in the example 3 margins. Okay, so we're going to talk about 3 different cases for horizontal asymptotes. Okay, so what I want you to do is write down case 1. Okay. So, case 1 is right there. All right, so case 1 says when the degree of the numerator is less than the degree of the denominator, there exists a horizontal asymptote at y equals 0. So, what are we comparing here? What is case 1 comparing? The degree, right? What does degree mean? It's the exponent, right? The highest exponent. So, looking at that example that you wrote down, what is my highest exponent? Sorry, what is my exponent of the numerator? 1, right? If there's no exponent, we can assume it's 1. What is my exponent in the denominator? 2. So, ask yourself first, are they equal? No. Is the numerator less than or greater than the denominator? Right, because 1 is less than 2. So, since the numerator is less than the degree of the denominator, what is our horizontal asymptote? Y equals 0. Yep, remember we need to be specific when we label these. Okay, so our horizontal asymptote on that one, by case 1, is that our horizontal asymptote is y equals 0.
So we look at the degrees.
Don't have to solve, you just compare the degrees. Yep.
And then we do by for even 2.
So that's case 1. Let's look at case 2 next. So I want you to write this case down right below your case 1.
How many cases do we have?
There's 3 cases. All right, so case 2 says when the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. Again, what are we comparing?
The numerator and the denominator.
What part of them? The degrees, right? So what this says is that if the degree of the numerator is greater than, then we have no horizontal asymptotes. So what's the degree of the numerator?
2.
2. What's the degree of the denominator? 1. First, ask yourself, are they equal? No. Is the numerator less than or greater than? Greater than. So, looking at the case, if it says it's greater than the degree of the denominator, then what's our answer? None. Yep, we have no horizontal asymptotes. You can just put none.
So B is none.
Yep. Last case we have to talk about is case 3. So go ahead and write down case 3 and the example right below it. I'm going to take out some words here so it's not as wordy. All right, so case 3 says when the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is the ratio of the leading coefficients. Again, what are we comparing?
The degree of the denominator and the denominator.
The degrees, right? What is the degree of the numerator? 2. What's the degree of the denominator? 2. So ask yourself, are they equal? Yes. So we look at the case where it says equal, which is our case 3. If they are equal to, it is the ratio of the leading coefficients. What does a ratio mean? Think like a fraction, right? Think a fraction, we're going to be dividing. Okay? What is a leading coefficient? It's the first number. What's the leading coefficient of the numerator? 2. What's the leading coefficient of the denominator? 1. So, to find our horizontal asymptote, we're just going to take 2 divided by 1. What's 2 divided by 1? 2. Can I just write my answer as 2? Other one. Y equals 2. Yep, horizontal asymptotes are always going to be written as y equals. Okay. So, you've seen our 3 cases. All the cases we are comparing the degrees. Okay? If the numerator is less than the denominator, the degree, that means y equals 0. If the numerator is greater than the denominator, that means we have no asymptotes. And then if our degrees are equal, then we take the ratio or we divide our leading coefficients. Okay? Keep those cases handy so that you can look back at them. Let's look at example 3a. So we're going to find the horizontal asymptotes. So what are we comparing when we're trying to find horizontal asymptotes? What are we looking at? The degree. What's the degree of the numerator on example 3a? 2. What's the degree of the denominator? 1. So I always tell people, ask yourself, are they equal? No. Is the numerator bigger or smaller than the denominator? It's bigger. So what case are we looking at? What does case 2 say? If the degree of the numerator is greater than the degree of the denominator, what's our horizontal asymptote? None. Yep, so our answer is just none. Okay, same thing with 3b. Look at their degrees. What's the degree of the numerator? 2. What's the degree of the denominator? Also 2. Ask yourself, are they equal? Yes. What do we do if they are equal?
Divide.
Right. What's my leading coefficient on the numerator?
1.
1. Leading coefficient on the denominator? 3. 1 divided by 3? 1/3, right? Or if you type that in your calculator and you did 0.33, that's fine. But is it just 1/3? What do I need with it? Y equals 1/3. Okay, that last one here. What's my degree of the numerator? 1. What about the denominator?
2.
Where do you get 2 from?
Because I combined them.
Right. It's in factored form right now, but we want to know what the degree is, so we need to combine them by multiplying. Okay, so I need to take 2x times x, which is 2x squared. Do I need to keep going? Why not? Because I have the degree. What's my degree? 2. So are they equal? No. Is the numerator less than or greater than the denominator? Less than. So what does it say our answer is if it's less than? Y equals 0. See how we're applying the different cases?
Yeah, that was easy.
Okay. Looking at example 6 in your notes, I want you to tell me what the horizontal asymptote is. And that's this example. I want you, it's not in your notes, so just go ahead and write it underneath example 6 since you have room. I want you to find the vertical and horizontal asymptotes of that function. Okay, so starting with our vertical asymptotes, how do we find those? What with the denominator? Yep, denominator, which is the bottom part of the fraction. Take that denominator, x squared plus 2x minus 15, set that equal to what? 0. So now that next step says factor and solve. How do I factor? Factors of 15, which are 115, 3, and 5. Which one of those is going to get us to 2? What do I have to change? 3 needs to turn negative. So when we rewrite, we have x minus 3 and x plus 5 equal to 0. How do I solve from here? Yep, set them individually equal to 0. So I add 3. What do I get for that one? X equals 3. Subtract 5 here, I get x equals negative 5. So remember, these two right here are my vertical asymptotes. Again, what does it mean to be an asymptote? What does it do?
Boundary.
It's like a boundary, right? Doesn't let it go through. Horizontal asymptotes, what are we doing? What do we look at? We look at the degrees, right? The highest exponent. What's my degree on the numerator? 2. Degree on the denominator? 2. So, are they equal? Yes. So we look at case 3 that says if they're equal, what do we do? Divide what? The leading coefficients, right? What's the leading coefficient of the numerator? 4. What's the leading coefficient of the denominator? 1. So 4 divided by 1 is 4. Is my answer just 4? What is it? Y equals 4. Okay. Again, this one is my horizontal asymptote. And again, an asymptote does what? It's like a boundary. Okay, the graph does not go through it. It does not touch it. It just gets very, very, very close to that asymptote. So what do we look at when we're talking about asymptotes, horizontal asymptotes? The degree. What is the degree of the numerator? 2. Again, the degrees are the highest exponents. What's the degree of the denominator?
2.
Also 2. Ask yourself, are they equal?
No. Yes.
They are equal, so what case are we looking at?
3.
Case 3, what does case 3 tell us? How do we find the horizontal asymptote?
To divide by the leading.
Divide the leading coefficients. What's the leading coefficient of the numerator? 1. What's the leading coefficient of the denominator? 2. 1 divided by 2 is just 1/2, right? Or 0.5. How do I write my answer?
Y equals 1/2.
Y equals 1/2. One more I want to look at today.